welcome to the very final video in my series on producing robust programs. Today we're going to be looking at test data. So, to test a program effectively, it is necessary to identify suitable test data and the expected outcomes required for that data. Test data should cover a variety of situations, and I've got a list here. We've got valid, valid extreme, invalid, invalid extreme, and erroneous. I'll explain exactly what each of those mean and give you some examples. So valid test data is test data that is a typical input for the system. Valid extreme, test data that is valid but is at the extreme end of the acceptable range of inputs. Invalid, test data that is out of range and should be rejected. Invalid extreme, test data that is invalid but is only just outside the limit for being acceptable. And erroneous is test data that should be rejected because it's of completely the wrong type of input. So let's give you some examples with a real scenario. Let's imagine a simple program that takes a number from 1 to 10 and prints it out on screen. It's something that you could create very easily yourself in Python or any other language. So valid, well remember, this is the type of data that is expected to be entered. So in our situation, this would be any number from 1 to 10, e.g. 5, right there in the middle as a valid piece of test data. So you put that in your program and check that it works as expected. Valid extreme. So we're testing data that is valid, but is right at the boundary of acceptable data. So in this case, we'd be looking at the number 1 and the number 10. They're correct, but they're right at the boundary of being acceptable. Sometimes we call this borderline or edge data. Invalid, well, this is data that should be rejected as out of range. So for example, in our program, 20 and minus 10 are clearly out of range and would be suitable test data for this. It should be rejected by our program. Invalid extreme is invalid, but only just out of range. So in our scenario, 1 and 10 are valid extreme, therefore 0 and 11 would be invalid extreme. They're just past that border. And erroneous data, well, that's data that's just completely wrong, such as a text string like A or hello, or a Boolean value like false or true. Data that just should be completely rejected straight away. For our scenario, you might create a test table like the one below. After you run each test, a screenshot would be taken to show if the result was expected. So you would create this for a big programming project. For example, your programming project maybe that you'll do in year 11, depending on what your exam syllabus is. But you would expect it to show that the program has been tested correctly and evidence for all of your tests. So let's put all that together. So our test data, we've got 5, and that is valid, checks if the input works. So our expected outcome is that hopefully it'll print 5, and then maybe we'll stick in a screenshot there to show that that works. And then we've got 1 and 10. These are valid extreme datas, and they're checking our boundary conditions. They should still work, should still print 5, should still print 10. 20 is an invalid number. It's just too big. So we'd expect an error message to be printed. 11 and 0 are invalid extreme. We've got numbers that are just too big and too small, and these should be rejected by our program. As should the letter A. This is erroneous. We want to check that the text I get all a bit tongue twisted here. That should check that the test is rejected and again produce some kind of error message. And of course our screenshots that we're going to stick in there should hopefully match our expected outcomes. Okay, I think that's enough about testing for me, and that's enough about robust programming. If you didn't understand something, go back, watch the videos again, check with your teacher, of course, and I'll join you in the next series of videos when I figure out what I'm going to do next. Good luck with your studies, and I'll see you in the future.